Okay, so Jiva, we're digging into the individual classes within the Foundation framework now, and I guess we're going to start with the one that people are probably going to use the most, or at least probably the first, strings.
Right. You know, a good standard library is really nothing without a really good string class. And so we're really fortunate that the Foundation framework has an excellent string class. And we've actually been using it all through these examples all along. And, you know, we've mentioned it a couple of times. So let's kind of dig in and take a look at that, look at some examples, kind of look at some of the details of exactly how you work with strings and what these kind of funky @quote things are all about. So let's take a look at an example. First of all, this is just a standard, you know, again, we're working with this standard Foundation template application here. And we've basically just defined a string here called SumString, and we've assigned it a value of @quote, this is a string. Now, the first thing to know is, first of all, strings are objects. So they are first-class citizens. You know, you can send messages to them, you can assign to them, and things like that. Now, one of the interesting things is the designers of Objective-C knew that strings were going to be something that we were going to be using all the time. And so they added this special syntax for declaring constant strings, this @quote syntax right here, where we're doing this @quote, this is a string. What that @quote thing does is it actually creates a constant string object right there. So that is, in fact, actually an object right there. In fact, if I wanted to, right, I could actually go just like this, and I could call methods directly off of that object if I wanted to. Now, you don't usually see that because it looks a little ugly, but you know, that's something that's perfectly legal because that is an actual object.
So the @ is saying, basically, I want a string object, and then the things in the quotes, and it's initialized with this.
Exactly. So you've got @, and then you've got quote, and then you've got some string of characters. That can be any kind of alphanumeric characters that you want. And then a close quote, and that makes a string for you. So in this particular case, we're making this string, this is a string, and we're assigning it to this value, some string, and then down below here.
Now, because that string is being created without an alloc or a copy or a create, it's auto-released as well?
It is auto-released, or you can assume that it's auto-released. I'll talk a little bit about that in a minute, because the truth is, it's kind of special.
Okay.
But you can assume that it's auto-released, and you can treat it as if it's auto-released.
Okay, right here.
So once you've got this string, then you can do stuff with it. In this particular case, I'm just logging it to the console. So if we just run this program, right, we'll see that it actually prints out our string right down here. This is a string. There it is, right? Another interesting part about this code, if you look at it, is in this NS log, right? We touched on this briefly before. We're going to talk about it in more detail here. But we have another string here that we're using in this NS log function, and I'm sure you can see it. It's right here, this @quote, and then %@quote. Now that's another string. It's just like the string that we were working with before. It's another string object. But in this particular case, it's a string containing a format specifier. Now, like I said, we'll talk about format specifiers in a few minutes when we talk about format strings. But I just wanted to point out, in case you were looking at this, hey, that's kind of interesting that that's a string there too. In fact, I could come in here, right into this code, and I can say my string value, colon, and then I can run that again, and what I get down here is my string value and then our string. So pretty straightforward stuff. So let's take a closer look at that @quote syntax, because that syntax actually creates a const static string object, which means that when you're working with these, it makes it actually really convenient to use these constant strings, like we've defined here, as keys, because it's static. The static keyword means that only one will ever be defined for that particular variable, right? So in other words, if I make, so let me give you an example. So here we're creating a string called string1, and we're assigning it the value of this is a string, right? Now, if I do that again, and I say string2 here, and I assign it the exact same value, this is a string, then those two strings will actually point, those two string objects will actually point to the exact same object.
Okay.
And it's allocated and it's just kept around so that you can do this. It's an optimization that the Objective-C compiler does. That's why I was saying, you know, technically you can treat it as auto-released, but technically it's actually not, because what happens is when the program is compiling your code, it actually just allocates these objects right in your code. In fact, if you go in there and you use an application or a command line program called strings, you can actually see all of your const strings right there in your application.
Okay.
So the point is, this optimization is done so that you can use these string constants, for example, in equality checks. So, for example, now if we look down here at this assertion here, string1 and string2, these are equal to each other, meaning their pointers are actually the same pointers. They're actually the same values.
So that's something that we didn't really cover in the earlier sections with equality. That when you have classes and you say, are they equal, you're actually asking, is this the same class in memory? You're not asking, are their values the same? Right.
And you know, I'll talk about that in just a moment here. But yeah, that's exactly right. In fact, actually, if you look down here, normally when you're working with objects, if you want to check for equality between the two objects, you use a special method that's defined on NSObject called isEqual. Because if you're actually comparing two objects, they will probably have different pointers. And so if you want to check to see if their values are equal versus their pointer values, then you need to use a method to do that, i.e. the isEqual method. If you just want to check to see if the pointers are the same, in other words, if they point to the same object, then you can use the double equals operator. But otherwise, you have to use this isEqual. Mm-hmm. But when it comes to const static strings, like we've defined here, you can actually use the double equals operator right there. You can actually use the double equals operator because they will be pointing to the same object in memory. So just to illustrate this point even further, right? If we then take string1, which was defined up above to be this is a string, and we say string with string, in this case, we're using a factory method. We're going to look at these factory methods in just a second, but we're using a factory method to create a brand new string object with string1. This will be a brand new object in memory, brand new pointer. So in this particular case, if we then look down here, string1 and string3 are not actually equal pointers. They will not, that assertion would fail. Now looking at some of these other things, right, you know, string1 and string2 will be equal because their values will be equal. String1 and string3 will be equal if you use the method off of NSObject because their values are equal. But again, string1 and string3, their pointers will not be equal because they're actually different objects. Now I make that point also because one of the places where this aspect of strings is often used is in, for example, looking things up. You know, if you use one of these and then you want to go if you use it as a key to go look up some other value somewhere, and if you're doing that lookup, if you're doing that equality test, relying on this functionality, that's okay for the most part. But if you then, for example, take that key and serialize it, for example, to disk, and then deserialize it, you're actually getting a brand new object. You're not necessarily getting that same object that was originally in memory. So in that case, you have to use isEqual to do that equality check. It might be a good idea to just use isEqual in general, but there's some cases where using that double equals operator is a little bit faster because it doesn't have to actually do the string comparison. All it has to do is compare two numbers. Does that make sense?
Yep.
So let's take a look. You know, I showed here this string with string factory method. Let's take a look at some of these other factory methods that are commonly used with NSString. So first up, there's, you know, if you wanted to just create an empty string, there's an NSString string factory method. And again, going back to our memory management rules, would this be auto-released?
Yep.
It would, because we don't have alloc, we don't have create, we don't have copy there. If I wanted to create a string with a bunch of other data, so for example, if I wanted to combine some numeric data with my string, if I wanted to make something like, in this particular case, I'm making a string that says some string with a number, and then it has a number associated with it, then I can use the factory method string with format, which allows me to use a format string and a format specifier, which we'll talk about in just a moment, to essentially insert another variable, another value, into my string when I construct it. So in this particular case, right, this formatted string here, this variable here, would actually wind up looking something like, it would say some string with a number 42. So what it will actually do in this particular case is it's taking that number, it's inserting it into the string where that format specifier, where that %LD is, and it's generating the string with all of that information in it. Another example here is, there is, of course, the copy NSObject method, which will get you a copy of objects. That should work with any object that conforms to the NS copying protocol. That's a protocol that's defined, an informal protocol defined on NSObject that defines several methods specifically for copying. But there's also several factory methods, such as this one, that also kind of do the same thing. In this case, this string with string will take our formatted string, for example, and will create another string based off of that. So we still have our original string sitting out there, that formatted string. That's still a valid object. If we reassign to that pointer or something along those lines, or if this were a mutable string, we'll talk about mutability in just a minute. If that were a mutable string, then if we made changes to that string, that would be making changes to that version of that, and it would not affect my new string. My new string is a completely new object. So this is the string with string factory method. There's also, if you're coming to Objective-C from C or C++, you may be familiar with the concept of C strings, which are essentially char character pointers that point to raw data in memory that represents essentially a string of characters, right? They're not a string object. It's just sort of a pointer to a bunch of bytes that happen to contain data that is characters. And so in this particular case, I've created this AC string, and I've assigned it the value of old school. And if I wanted to convert that to an NS string, then I could use the string factory method, string with UTF-8 string. Now, one important point, when you're looking at the documentation, you may see that there's also another method out there called string with C string. That method is deprecated because it doesn't handle UTF-8 encoding properly. And you want to make sure that your code is easy to it handles UTF-8 so that you can handle international letters and things like that, right? Mm-hmm. You know about that.
I do.
So that's the string with UTF-8 string. And there's actually some other factory methods in there as well that allow you to specify different encoding. UTF-8 encoding is probably the most common one, but there are other factory methods that allow you to specify the exact encoding. Like I think there's UTF-16 and things like that.
There's a whole range. It means you have to get into understanding all the different
yeah
coding systems for strings.
And generally speaking, I mean, I can't tell you that I have ever written any code that ever uses any of those factories. I'm sure that there's cases where you probably will, but probably in day-to-day use you never will. So another cool thing is you can actually create a string by just reading in a file, which is really awesome, because if you've got like a file out there that's just that contains a bunch of data, like an XML file or something like that, you can just read this file in, and then you can do all of your manipulating and parsing of that file right in memory. So to do that, there's this factory called string with contents of file, and then you just pass it a path to your file. In this particular case, we're doing /temp/somefile.txt. Again, you have the option of passing encoding here. So again, here we're using NSUTF-8 string encoding to specify that the file in question is encoded using UTF-8. And then remember when we talked about error handling, right? This is one of those APIs that has been updated to take an error pointer to a pointer. So if you used this method and you got back a nil, right? So in other words, if from a file here returned nil, then you could check your error to see what error occurred.
See why it went wrong.
Exactly. So that's that. Now there's also another version of this, which is kind of cool, which will actually try to figure out the encoding for you and will tell you what kind of encoding it was. So that's another version. Generally speaking, again, 99% of the time, you use NSUTF-8 encoding, and it'll work out fine. Finally, there's another factory method here that'll actually let you go get a file from the web, and this will actually do everything for you. You specify a URL, and actually there's an error here because this should actually be this actually has to be an NSURL here, and then URL with, I think it's file URL here. That might be wrong there, but the idea is you create an NSURL object, and so here we're passing this string. But what will actually ultimately happen here is it will actually go out and access the web. It'll download this file from whatever URL you've specified and return its data in the string right there.
So we need to check the syntax on that NSURL call. But basically, you're saying use some sort of factory method of the NSURL class that takes
to create an NSURL,
and then you can create a string from the return of that URL.
Exactly, and it works just like the string from contents of file, in that you're passing in the string encoding and you're passing in an error object, and if you get nil from that, then your error will be in your error object. Now, one other important note about this, you might look at this particular call and you might say, well, gosh, this is really easy. I don't have to do anything to go interface with my web service, right? I can just go grab my data off of my web service and I can just use this method to do that. Like, for example, in your, say, iPhone app or something along those lines. Well, the problem is this call will block until it gets the data. So it's not really particularly smart. And when I say it'll block, what I mean is it'll block the current thread, which includes, in an iPhone app, typically it'll include your main GUI thread, the thread that's running your run loop. So in other words, if you go and use this method and you don't do anything special like launching a background thread or something like that, your application is going to stop. And if the user tries to push any buttons, nothing's going to happen. It's just going to sit there and wait until it downloads that resource.
And if you're on GPRS or Edge or something, that's going to take a while.
It's going to take a while. So generally speaking, I mean, while this convenience method exists, and it's okay for use if you are making, say, for example, a command line app or something like that, where it doesn't really matter if your app locks, while it's downloading this thing, then that's okay. But probably if you're doing something like a GUI application, an event-driven application, you should really use something like NSURL connection or something like that to actually do your downloading of resources.
So, I mean, basically here you've just picked a few of the factory methods off of NSString. I mean, NSString is a huge class, really,
yes,
with loads of different methods attached to it. So people really need to go to the documentation
absolutely
and have a look. But at least you're going to understand what you're looking for and see these many different methods. Now, okay, I mean, we're scratching the surface. What else do we need to know about NSString?
Well, you're right in that there's, these are just a few of the factory methods that are out there. There's tons out there, but I did want to spend a little bit more time specifically looking at some of the factory methods that work with format specifiers, because I don't know about you, but probably, 80% of my string handling code deals with format specifiers, like, you know, making, sort of constructing strings to match a certain format.
I agree. And
So-
I can never remember them. So
and I can never remember them
always
either.
looking them up.
So the important thing, so first of all, you know, let's talk about what a format specifier is and what a format string is, okay? Essentially, Objective-C, well, really this actually comes from C originally. These were developed as part of the printf function in standard C. And essentially what it does is it enables you to do something like this. You can say, well, using printf as an example, which is an old C function, basically you can say printf something something, and then you use these special characters, percent, and then a string of characters that indicate that basically key to tell what kind of data I want to insert into here. Probably one of the ones that we've seen most frequently in our examples here is LD, okay, which actually means long decimal, right? And so by using that, right, then I say quote again, and I terminate my string. Then I say comma, and then I can have a list of arguments. For example, let's say n, right? And I can have multiples of these. I can have, you know, x and y and so forth. And then, but I do need to have as many arguments here as I have of these special, what these are called format specifiers inside of these, inside of the string. So if I, you know, I'd have to have %LD again, and maybe one of these is a float, %F.
I mean, they don't have to be in a row like that. They can be anywhere in that string, those specifiers.
Correct.
Yeah, so...
they can be anywhere. You know, I could have other things in here. I could have something there, and so on and so forth. And what actually happens is at runtime, not at compile time, at runtime, when this code is encountered, it will actually take each one of these variables and take its value and try to convert it to whatever you've specified here. In this particular case, again, a long decimal, right? It's going to say, I think this is a long decimal, and it will then stringify the value and put it into your string. Okay? So looking at examples using actual strings here, NSstrings, first of all, we have this NSstring here that we're just declaring. We have this string variable, and then we have a card name, ace, and we have a card suit, spades. These are both also strings, okay? And here we're actually using one of these factory methods, string with format. The string with format factory takes a format string, just like we were just talking about a moment ago, and a list of arguments after it. So, and it takes those and it will make a string based on that format string and those arguments. So in this particular case, we're making a string that says the winning card is, and here we're using a format specifier of %at. And we've talked a little bit about %at before, but I'll mention it again here. The %at format specifier is specific to Objective-C, and it is specifically designed for putting objects into strings or converting objects into strings. And what it actually does is it knows that whatever it is an Objective-C object, and it will ask that object for its description method,
Right.
which is a method on NSObject. If you don't override it in your own classes, it actually just prints out essentially your pointer address. But if you want to have a pretty description of whatever it is that you've built there, then you can override description in your own classes and have it print something that's descriptive about your class.
So, for example, if I had an employee object, I could override the description method of the class to return a concatenated string that represented the first name and the last name.
Exactly.
We'll talk about concatenation, I guess, in a minute, of the last name. And then if we were then to write a string with format here, %at, and pass our employee object, what we would get is that string.
Precisely. And we'll actually see in the upcoming segments, we're going to see this %at used several times, and you'll see it used with different kinds of objects, and you'll see kind of the different kinds of descriptions that the developers, that the API designers have built for these different kinds of classes. In the case of NSstring, the description method just returns the string value. So essentially doing this means take this string and stuff it into my string. So if you look below here, the comment here, it says the string is now, the winning card is ace of spades, because what it's done is it's taken that card name variable and it's stuffed it into the string as ace, and it's taken that card suit variable and it's stuffed it into the string as spades. Same thing with the next line of code here. In this particular case, we're using another one of those %LD format specifiers. Again, that's a long decimal, and in this particular case, it's just saying player gold amount. So basically, this would be taking a long integer and putting that into the string where that %LD is. So we would see that right here, that you have 1,000 gold is kind of what you would get out of that particular line of code. Now, one of the interesting things about these format specifiers is that you can also specify as part of the format string the format that the accuracy of the values that you're working with. So when you're working with, for example, floating point values, you might have, let's say you wanted to print out pi to a certain amount of digits, right? You can specify how many digits out you want to print it to, although technically, I mean, it wouldn't get very far because the pi value is, you'd have to write a program to actually calculate it to a large amount of digits. But, for the first few digits, you could easily do a format string that just does % and then decimal point and then the number of digits and then F, which indicates a floating point value. Mm-hmm. So now if I wanted to, in other words, in this particular case, I'm specifying that I have a value here that I want to print to 2 decimal point accuracy. You could also do the same thing on the other side of the period there to specify how many digits in front you want to have on there, and it'll fill those in with zeros if you want. So that's an example of how you can use these format strings to do all kinds of interesting stuff with strings. Now, format strings are a really, really complicated subject, and I mean, I've been writing code for 15, 20 years, and I don't remember half of the format strings myself. So the best thing to do is probably to go ahead and look at the documentation for format strings in Xcode. If you just type in format string into the Xcode documentation, here's a list of all of the different format strings that are available to use when working with these string with format methods. And feel free to look at this, and it'll make much more sense after you've read through the documentation there. So that's string format specifiers. Now there's one more thing that we kind of need to cover with regard to strings. And we'd be very much remiss if we didn't mention this. If you've been paying close attention, you've probably noticed that I've created all of these strings. I've been, putting things into strings. I've mostly been creating all new strings, right? But if you notice, I haven't made any modifications to any of these strings, right? NSString is one of a few classes in Objective-C that actually has 2 variants. One of them is an immutable variant, which is NSString, and then the other one is a mutable variant. So in other words, one of them you can't change, NSString, and one of them you can. The version that you can change the value of after you've created it is NSmutable string.
Okay.
So let's take a look at that real quick. So again, if you're working with just a plain old NS string and you make an NS string, there is a method on NSmutable string called append string. And if you were to try to use that method, so in other words, in this case, I want to concatenate foo and bar together, right, by appending bar onto the end of foo, this wouldn't work. This would give you a compile error because there is no append string method on NSstring. Append string is part of NSmutable string, okay? So in this case, I've actually created an NSmutable string called mutable string, and I've done it by creating this NSmutable string with string. Now, notice I had to use this factory method here because when you're using the @ quote syntax, that is an NS string. It's not an NS mutable string, and it's constant. You can't change that. So you do have to create a new string here with one of the factory methods.
But NS mutable string, I'm assuming, has all the same factory methods as NSstring.
Right.
All the same string formatters. It's exactly the same. You could do all the same things with it as NSstring. It's then got the extra functionality to make it mutable.
That's exactly right. And why is that? Because NS mutable string inherits from NSstring. So it's using that object-oriented programming stuff, right, to inherit from NS mutable string. So that means it gets all the same functions that NSstring gets, but it adds on mutability.
Now I'm guessing this has been, I may be totally wrong here, this is a guess, that this has been done this way, and with a number of classes, and we're going to talk about a number of those classes we go through, because things like strings, arrays, which is another one, are so common that when you have something like NSstring that the compiler knows is not going to change, it can do loads of optimizations with them.
That's exactly right.
If it's going to change, it couldn't.
That's exactly right.
So really, I mean, some people might say, oh, well, I'm just always going to use NS mutable string then.
Right.
But actually, that's not going to perform as well as using NS strings where things aren't going to change because the compiler can do lots of magic.
Yeah, I think that is definitely why they originally did it that way. Now, whether that really continues to apply in today's world with the size and speed of computers that we have today, maybe, I think there's definitely cases, probably if you're using Objective-C for any kind of high performance computing, you probably want to be careful about using NSstring when you can, because yeah, you're absolutely right. That's why it was done that way, was so that there were because it could do special optimizations if it knew that value wasn't going to change. I think that applies a little bit more when you're looking at like NSArray and NSMutableArray, because, for example, in that case, NSMutableArray has to allow for its memory to grow in a much greater way than, say, just working with strings. Although I guess arguably, if you were to stuff a lot of data into a new string,
I could load a new 4 gig file into it.
You could load a new 4 gig file. You could try anyway. Anyway, so the point is, I just wanted to look at a few of the things that the mutable string gives you so that we're familiar with it. But the important thing to know is NS mutable string is just an NS string with mutable stuff on it, essentially. So looking at that, so once we've got this mutable string here, then we can actually do this append string. And here we've appended that bar value there. So now our string would actually be foo bar. That's what our string would actually be here. Same thing we can do. We can also do the same thing with format strings too. So for example, if I had a number 10 and I wanted to append to the end of my string maybe some more string characters and that number, for example, hyphen some number colon, right? Then I could do that using the append format method. And here, at this point we would have foobar dash some number colon 10. Boy, this is really like useful text that we're putting onto the end of this.
You write some really interesting programs, don't you?
I do. I gotta keep my life interesting. Anyway, okay. You can also replace strings inside your string. So for example, here we're doing replace occurrences of string bar with string baz. And in order to do that, you have to specify some options for your search. In this case, I'm doing a case-insensitive search and a range of the string to replace within. So now, after that method, then you would actually wind up with this foo baz dash some number colon 10. Finally, and again, these are just examples of the kinds of things that you can do. You can also insert new data into the middle of that string. And I think that's probably one of those areas where the optimizations come into play, because inserting right in the middle of the string means you now have to open up a whole new bunch of memory at the end of it and copy all that data down, which is a pretty performance intensive thing. If you know that you never have to do that, then that's a cool thing. So to do that, then you basically use the insert string method, and then you have it insert at whatever index in the string that you want, and the end result of this particular operation would be foo-baz some number colon 10.
Lovely. I mean, again, this is about changing the contents of our actual string. We have a mutable string, and it's about changing its contents. Sometimes you want to put two strings together, and it doesn't really matter that it's the same string. So NSString itself, the immutable one, has a number of methods that says, add these two strings together. But it gives you a new NSString as opposed to a changing the original one. So if you don't necessarily need to have it be this string, you can still do sort of string manipulation to a certain extent on different things, as long as you don't mind getting a new string.
You're going to get a new one back.
A new string back. And sometimes even that is going to be more optimized than keep messing around with a mutable string.
Right.
I guess on modern hardware it's not such an issue, but again, we like to do
it depends on what you're doing. I think it's important to know that it's there, and I think it's important to know that I guess the way I approach it, generally speaking, is I try generally to write my code towards NSString, because I like to have sort of proof that I need more than that before I actually go out and just get it, right? So I generally will write my code towards NSString until I find, oh, hey, I need to do this, that, or the other thing. And then I'll just refactor my code and change things to NSmutable string when I need to. So that's it. That's NSString right there, which is, that's one of the probably most used classes in the Foundation library. And, you will come to know NSString intimately in your Objective-C programming career.
Sounds good.
Indeed.
What are we going to get to know intimately next?
Oh, gosh. What are we going to get to know intimately next? I believe it is collections.
Collections. So, you've heard it here. Get excited.
Bye.